Hi all, welcome to Pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. In today's session, we will be looking for fundamentals and toolbox of the particular MATLAB Introduction, installation of MATLAB, matrices in MATLAB, it is known as the matrix laboratory. So this particular matrix laboratory, it is completely used only for the purpose of calculation, and they have designed multiple kinds of algorithms by using this particular MATLAB. It is not a software which is situated for a particular domain. This is a multiple domain using software. It has been developed in the year of 1970s as a teaching tool. So here, what and all kinds of implementation we are allowed to do means numerical computation, data analysis, plotting and visualization, graphic user interface building, and algorithm development and modeling. Inside the MATLAB, we are allowed to do the programming in 4 languages like C, C++, Java, and Fortran. While compared to other softwares, this particular software is most suitable for multiple domains like electrical and electronics, aerodynamics, mechanical design, electronics, circuit design, deep learning, machine learning, image processing, signal processing, audio signal processing, embedded systems, VLSI, etc. So this kind of different domains which have multiple specialties, it can be easily operated by using this particular MATLAB. So here, this particular MATLAB, we are going to use it for a single purpose known as image processing. What are the tools available for MATLAB? The most important tools which we regularly use are command window, command history, workspace, and current directory. So here, this is the MATLAB software. Within this software, this is known as the command window, current folder, and workspace. So if you want to write any of the codings inside the script, click on new script, and therefore here we can enter that complete scripts over here. After entering the script, by using the run button, here we will be able to execute each and every kinds of function. What are the general commands that has been used for this kind of MATLAB means CLC, clear, close all. So this complete command, it will be placed in each and every starting of the script of code. Like CLC, it is used to clear the entire process, whatever it is present on the entire program after executing a particular function. Clear means to clear only that particular workspace. Close all, it is used to close the windows, sub windows that has been opened inside the MATLAB whenever you are performing any of the execution. Save, load. Save, it is used to save any of the data inside the workspace. Load, it is used to load the saved data from the workspace. Who and whose. So who and whose are used for the finding out the purpose, to find out any of the particular files in the current directory or in the workspace. CD is used for change directory. Edit, to edit the particular kind of input. List, it is used to list out the complete files inside the folder. Input, to provide any sorts of input data. It may be in image, or it may be a CSV file, or it may be a single number. Display, it is used to execute that particular kinds of output inside the command window. So display version means to display any kinds of the particular version, and this particular command, it is rarely used. mkdir, it is used to make directory, and here delete, to delete any of the data which is present inside the current directory, or any of the data that has been generated from the code. Size and length, to decide the size and length of each and every file which has to be created or which has to be compressed. What are the most functions of MATLAB? The functions are most similar to that particular scripts whichever we create inside the code, and MATLAB also support the function by taking the multiple arguments from different files. So inside MATLAB, there it doesn't have any kinds of header files. Only the packages and toolbox are most important. So here it is also allowing the multiple parameters to enter the data for various functions. So we will come to know once whenever we start to work regarding towards many kinds of programs. So from that, how the functions are being called, and at the same time how the arguments are being taken. So without header file, how that particular data are being imported. What are the different plots that MATLAB allows means linear plot, discrete plot, grid lines, x-axis label, y-axis label, add graph title, divide figure window, create new figure window, wait for user response. Default, how the MATLAB works based on the matrix section means identity matrix variable equal to I within bracket m comma n, which is known as m cross n. If you are going to use ones matrix means ones m comma n, zeros matrix means zeros of m comma n. So these and all the array function where whatever the data it is able to collect, like the CSV file or that image file or any of the plotting data. So all the data here it will be converted into the array. So normally for most of them are if anyone is familiar with Python means I can relate it to the NumPy. So same like the NumPy package only, this matrix package also will be working. So for that each and every functions are known as I, ones and zeros. So I is known as identity matrix, ones is known as ones matrix, zeros is known as zeros matrix. So similarly, if you want to create any of the square matrix means you have to provide magic as the command, and uniformly distributed matrix means you can take it as RAND, which takes the matrix in a random basis of manner. To generate the self data, for that purpose, we will be using this random numbers. So this is the complete workspace of the MATLAB. So here I am using the MATLAB 2018 version. So within this particular tab, we have multiple options like new script, new live script, new file open, and find the files, compare the two different files, import any of the data, save workspace automatically. And also we have some functions like new variable, open variable, clean the workspace, favorite, analyze code, run as well as record its time, clear previous commands. We can also open the Simulink for simulation purpose. Now I have opened the particular Simulink. It takes time to display. So here we can change the layout according to our view. So this is the default view, whatever you are seeing now. 3-column view, command window maximized view, only command window. And if you have any other layouts, that particular layouts also can be saved. I prefer always default. So based on your requirement, you can just keep the required toolbox. And to set path for that particular directory as well as the preferences. If you want to add any of the packages, you can use add-ons. These resources part it is used to communicate with the community of MathWorks. So these are some of the different plots available inside the MATLAB. Once when we start to provide the data, these plots will be enabled. Other than image processing, what are the different apps available inside the MathWorks means curve fitting optimization for machine learning purpose, PID tuner for control system, analog input recorder, audio processing, system identification, wireless waveform generator, signal analyzer, image acquisition, instrument control, sim biology, MATLAB coder, application compiler, classification learner, design deep network designer, neural net clustering, neural net fitting, neural net pattern recognition, neural net time series, regression learner, curve fitting, distribution filter, optimization, PDE modeler, control system designer, control system tuner, fuzzy logic, linear system, model reducer, MPC designer, neurofuzzy designer, PID tuner, slam map builder, system identification, drive scenario, ground truth labeler, MBC model fitting, MBC optimization. And this is all completely for signal processing for communication as well as antenna design, which contains both 4G as well as 5G Simulink. And this is for the computer vision techniques. This is financial mode of computation, biological sequence, code generation for VLSI devices, code verification, application developer like Hadoop compiler, library compiler, web app compiler, database connectivity and reporting generator, 3D animation. So these are the different apps that is available inside the MATLAB. Image processing. So you will get many files. Among that, you are only allowed to choose MathWorks Toolbox. So here, which kind of toolbox it is required? Those toolbox and all can be installed over there. So how to install means? So here I will show which is not installed previously. This is just a demo. Once again, I give you instruction like do not install any other package other than MathWorks. So here for demo only, I am choosing this particular package. So click on this add and click on add to MATLAB. So after that, it will ask the license agreement. Click on agree. And another one requirement for installation is mail ID is must. So you have to log in with your mail ID, which you have created for MathWorks account. Else it is not possible to download at all. So now it has been installed. So now we can manage. If you want to delete it, we can delete it. Or if you want to remove it for a temporary it is also possible. So click on manage, go to the respective folder, click on uninstall. If you want to disable this temporary means, click on this tick mark. So image processing toolbox, computer vision toolbox, these are the two important toolbox, as well as image acquisition toolbox. These three toolbox are most important for image processing purpose. And here the MathWorks toolbox, you can see. So like that, it should be watermarked over there. Here also you can see the MathWorks logo. Only these add-on packages you are allowed to download. Now in Simulink, to provide any kinds of simulation, we will be using the Simulink process. Now I'll just provide an intro in Simulink. Yeah, therefore the workspace has been opened. So from this workspace, this is the library. So here, these are the different blocks that can be used for multiple domains like HDL, fuzzy, embedded coder, DSP, deep learning toolbox, data acquisition, computer vision toolbox. This is used for image processing purpose like analysis, enhancement, conversion, filtering, geometric transformations, morphological operations, sinks, sources, statistics, text and graphics, transforms, and utilities. So this was just a basic software intro. Now let us start with the program. How to do a sign plot in Matplot. So here I will just explain the code. First I am providing two variables like t as well as y. So here the t, I have provided that particular intervals as well as how much it should be separated over there. So from 0, 0.25 is to 7. So this will be that particular ratio, whatever we have provided. And here also you guys can see how that particular plotting also is being done. So now y equal to sine of t. Sine indicates that particular sine wave. So whatever the data we have provided, according to that only the sine also will be provided over there. And now I have to plot that particular data t comma y. So t comma y means these two data will be plotted x comma y axis. Now if I want to label that x axis means x label within bracket quotes the respective name. Now y label within bracket comma y axis. So I can provide any names over there, and the title of this entire graph can be provided as title within bracket within quotes any names for that. And finally grid on in the sense to see this grid lines. If you don't need any of the grid means no need to provide this particular line. In case if you want to provide that particular text inside the graph means g text known as graph text. So within bracket within quotes you can provide any of the text over there. So now I will just show it in practical. So here I am providing. So here it will be a little bit difficult to see. So therefore one of the visualization has been completed. Now let us try by running this code. To run the code, after typing in script, go to the editor and click on run. So here first we have to save it, and therefore here I am saving it in one of the folder. So here I am saving it as some name, and all the extensions will be saved in .m. So here it will be asking whether you have to add to the path or change the folder. So click on change to the folder, and therefore here the folders will be redirected. So now here we have got that particular final value. So by pointing at any of the places, we will be able to note it down. So what are those values? Now if I change this particular 0.5 value to 1, so now you can see the particular orientations has been changed. Now X label. So until I close the quotes, it will be showing it as red only. Y label. So here you can see that y-axis and x-axis is equal to 1. So now I am displaying it without grid. So only with the help of grid only here we will be able to see the text. Okay. So this is known as the plotting of data in MATLAB. So this is the cosine value of that same plotting. So in case if you are saving any of the data over there, therefore we can use this particular plot. So here I have selected the variable from the workspace like A and B. Now here you can see those two variables has been selected. Even I can interchange by clicking on this. And after that, if I select the plot, so this is the basic plot which we have applied. This is multiple plotting, shaded plotting, bar graph plotting. This is scattered plotting, pie plotting. So based on the pie chart also it will be plotted. So automatically whatever we have provided the variable, it will take that value, because here we have given that variation. Histogram plotting. This histogram plotting will play a major role inside the histogram equalization process inside the MATLAB image processing. This is semi-logics. semi-logy, this is log, error bar, stem plotting, stair plotting, this is 3D bar graph, polar plottings. For the values which we have given, for that the polar plottings also can be applied. So geoplotting can only be done based on the latitude and longitude values. Now, according to the data, it has been printed. This is can be applied for satellite image plottings and all. 3D ribbon plotting, vector field plotting for weather section, the compass, quiver, scattered histogram. So this particular plot is combined with both scatter as well as histogram section. Curve fitting tool. Based on the live data, only the curve fitting tool will be applied. So here we have not provided any of the live data. This is mapping toolbox. According to the cosine value, now the data has been applied. This is for filter section. Whatever the filters we are using for audio processing, for that kind of display we can use this. For example, this is for step response. So this is completely based on the step response graph. This is for impulse response, and these are the spectral estimation. So for this, if you want to get the actual data, you have to try with the spectrogram. So now I have plotted the maximum graphs as a demo. Now let us clear this. How to save and load a variable inside the MATLAB. So to load the variable or save a variable, it is very simple. Like here I have to provide the function like name as save, and previously I have declared the particular variable also, and therefore that particular variable will be automatically saved inside the workspace, and therefore I can also call that particular area for the next applied code. So that particular demo, here I am providing the value as equal to 7 save. Okay, so now I am going to save this particular data, and whenever you are saving this files in .m, never save the files in a exact manner. For example, image processing should not be saved as image processing. Why means once again, whenever you are running any of the function, for some of the function name, there are chances to be image processing. So kindly don't save. Better to save this kind of data like this, like SAV, GR, so that it won't interrupt over there. Else it will be throwing out an error. And here now I have saved the data. Now I am going to load the data. So here I am going to provide load A and B equal to 15, C equal to A plus B. To print out the data, use disp of, I'm saving it as low. So 67 plus 15, it is 82. So like that, we can take many sorts of data and save it in the workspace. And from there also we will be able to apply it. Type GUID, which is known as guide, and therefore one of the pop-up menu will be appeared over here. So this particular pop-up menu can be set as blank GUI, GUI with UI controls, GUI with access and menu, model question dialog. Since we have to design our own GUI, we are going with blank GUI, which is the default option, and that particular data will be automatically saved into the folder from which the access has been taken. If you want to open any of the existing GUI, click on open existing GUI and select the required path and its file. So now I am clicking on OK, and hence everything is displayed. So everything is displayed in the sense, therefore the automatic codings and everything, it has been applied over here. According to the design, whatever we do on the work area, here inside the coding also it gets automatically changed. So first get into the section and decide the size, how much you require. So if you want to increase the size means click and drag. If you want to decrease the size means drag and drop. Okay. So here we have many kinds of functions like button, slider, radio button, checkbox, edit text, static text, pop-up menu, list box, toggle button, table, access, panel, button group, ActiveX control. From this, today we are going to see how to access the button. So I have selected the push button. Now I am going to draw that particular button size. Okay, so this is that particular push button, and if you want to do any kinds of editing inside this push button, right click, go to property inspector. So here only we will be able to edit what kinds of requirement. So the first thing, I would like to change the name. So for that, here I can select the string. So click on the string. So now I am going to create for load section, and I am going to give it the name as, I will go for save. Click on OK, and therefore the tag name for this particular button, it is nothing but push button 1. If you want to change, that can also be applied, no issues at all. Now I'm going to design another one button. Right click, property inspector, change the string into load. Okay, so therefore two buttons has been created. Now let us create some functions over here. So now I am running this just to change the functions in code, and therefore this is our design. So here push button 1 is for save and push button 2 is for load. So press enter under that particular function and type the required one. Here I am providing d equal to numbers and I am providing the function for save. Now whatever that has been saved over there, I'll be taking it as in different variable, and whatever the value we have taken, it should be displayed. So now I am running this. Yeah. So first I am clicking on save. So here the first parameter in which variable we have to save. The second parameter, what is the data we are going to save. Yeah. So that particular function has been saved. Now load it. So in this way only, here we will be working with the GUI button. Now the same thing, if I want to display it in the GUI itself means, so get back to our GUI, select any of the text function, and here I am going to take the static text. So here I am erasing the thing, only the numbers will be displayed. After that we have to run the code and enable that particular function. So here the name will be in the form of text. So which data we have to print means we have to go to that particular function and type handles.text1. Handles, it is nothing but whatever the GUI we are using, and text1, it is its variable. So in which way we have to print it means in the form of string, and we have to provide that required variable. So now I am going to first save the data. Data has been saved, and load the data. Oh, so here it has been changed as text2. Sorry for that. So here we can see that static value. To increase or decrease the font or to change that particular font size, everything that can be done in property inspector. So here you can see the font size. So click on this drop down and I can make it to 24. Run the simulation, save, load. Now the points has been increased. So this is the way we will be able to create a button as well as display the value inside the button GUI, which is a little bit interesting, as well as it is also a slight important once whenever we are working with this image processing and for advancement functions even in MATLAB. So this particular kinds of functions are more easier and much more important to work whenever we are working inside the software tools. So as we have said, how to start means guide, open that particular function. So if you want to create a blank one, you can click on blank. So I'm going to create an existing one. Therefore, we can go with previous file. Okay, so now it is opened. And yesterday we have tried for the functions like save the data and load the data. And whatever the data has been saved and loaded over here, it is able to display. Okay, so now we are going to just work on the same thing with another functions inside the GUI. So here I'm going to delete these two buttons, also these two functions. So here we can try to create a new application. So here we are going to take another kinds of function which is known as slider. So first click on the slider and we have to create that particular slider range, and therefore this is known as that particular slider. Once we will be able to run only when it is being applied. Okay, and inside the slider itself I'm also going to add the edit text, so making a little bit bigger. Okay, so what is the purpose of this edit text means we are also able to edit like input as well as output section. So here I'm just going to integrate both slider as well as edit text, and therefore I will be able to apply that particular area, so that whenever I'm moving the slider the value also getting changed. So first let us set the property. So inside this property, yeah, so everything is normal, and this is the tag name known as slider1. So now get back to the code. So this is the movement that has been provided. Yeah, so here we have our that particular section, and here it has also provided some if condition. So here no need to provide that kind of if condition because we want to get that complete movement in a single way. So here they have given for the color section only. So now I am deleting that. So like yesterday, whatever we have given, first we have to provide a variable and we have to get the value. So from where we are going to get the value means from the slider, because slider is a variable one. So from that particular variable one only, here we will be getting the input, and edit text is nothing but the output section. Sorry. So here this is that particular access part. So from that particular access part, I am giving a name known as value in the string. So therefore, whatever the value we are providing, the range of value, from that range only the slider will be working over here. And here I have to create that particular section. Now I am going to provide the data. So the particular range, it is nothing but so 0 to that respective value. Now I have to edit that particular text edit function. Okay, so now it is working well. So now I'm going to just display the function over here, whatever we are reading. Yeah, so now it is able to get the value. So before that, I will just convert this particular data. Okay, so in this function, it is not able to enable that particular conversion. So I hope it will be better if you are going with the number data itself. Now we have to set the value for output section. So for that, here we have to set handles dot edit one, because in this place only yesterday also we have applied that particular static text comma from where we are going to get it. So we have stored the data inside the value in the form of string. I'm extremely sorry for my particular system's problem. But inside the edit text, we have not edited our property. Just I'm going to the property inspector and editing this as empty one. Yeah. Now we have to provide a basic data over here. So what is the purpose of basic data means for this value input. Now I am providing. I hope there are some issues with my MATLAB because it is not getting with some of the functions. Okay, let me restart my MATLAB once. Kindly wait till that. Yeah. So this is the file we are using and I hope now it works. Okay. I think there is a serious problems with my MATLAB. Let me check with the problem of GUI. Yeah, so whatever here it has been provided is correct only. Initial value is 0. Okay. So here first I'm taking slider and I am expanding that particular slider. So this can be done in the form of vertical or horizontal. I'm taking the edit text. So inside the edit text, I'm clearing out the string. So here also value it is in the form of 0 and here also it is taken as slider 1 and edit 1 and the value is 0. Yeah, again the hanging problem is there. So here I have created and therefore I'm going to execute it as new file. Yeah, so therefore this has been saved as a variable named WR. Okay, so here I'm getting back to the function of GUI. I'm providing a variable named as val equal to get within bracket handles. So handles, it is nothing but wherever the GUI that has been updated over there dot slider one. It is the variable name or the tag name that has been provided. What value I'm going to get means there is a default name of value inside that particular slider. So there is a particular function. So from here I'm going to get, after getting that particular value, I'm going to set it in edit text handles dot edit one comma string. So what I'm going to get it as input means BAL. But this will be that particular exact function. So the problem whatever I am facing, it is due to that MATLAB software. Let me check once again. Let me find out that particular error. There is issue with my MATLAB only. That's why it is simply throwing this error. And I hope everyone is able to see this. Kindly wait for 2 minutes. Let me check what is the issue. So open guide and I'm creating a new one. So first I'm taking this slide and I'm taking the edit text function. So here now I'm creating my callback. Okay. So from this particular callback only here we are going to apply this function and the function is handles dot slider one within quotes value and therefore here I'm going to set the particular data handles dot edit one within bracket string comma val. Okay, so now it is able to slide the data but there is no such change in that particular value. We are obtaining the change but it is not a normal one. If you want to change into that particular data, go to the properties, select the maximum and minimum value. So let the minimum value be in 0 and maximum value in 100. So here we don't need to take conversion of any of the data over there. We can directly run to it. Okay. So this is known as that particular slide. So this is known as creating the slider using the MATLAB's function. Okay, fine. So this is nothing but the function of the particular data whatever we have provided. Now within this itself we have to use another one function known as axis. Okay, so axis is nothing but known as some of the display part. So inside this we will be able to display any kinds of requirements. Okay, so this is like a box, maybe the picture or the plot, anything can be done. So for that we have to use within bracket axis handles.access1, comma, what kinds of function we are going to provide. Okay, so now I am also going to create this function. So like within access handles.access1, comma, val. So now here nothing will be displayed because whatever the data I have provided, it is in the form of string. Okay, so here I am providing another data like plot function, and now this will be displayed. So you can see how that particular graph is being changed over here, the graph sections. If you want to get that particular plot data means here we have to assign. So just I will take yesterday's section. Okay, so this is known as plotting using slider. Image processing, it is nothing but converting one sort of image into another. So whatever the images which we have learned, which we have seen in our olden days, it is known as completely analog images. So this particular analog image, which we take in that particular normal camera, we will be taking into the film, and that film will be converted into the photo sheet, which is kept inside the dark room. Now whatever we are using, it is the digital type. Let it be our phone or let it be the digital type camera. So therefore we will be taking that particular click, and therefore that particular click, whatever we apply, it will be converted into the bytes. So this particular image, whatever we are using inside the digital cameras, everything, there are some sort of process, because a real time it is being captured into the image, and we are also obtaining it in the form of same color. So that's nothing but known as the process function, where this particular process is obtained means for hardware purpose. Okay, so other than hardware, where and all this particular application is done means some of the software sections like a web page, or we can go for background image background inside any of the sections, or providing the watermark for any of the softwares. And also we can say some of the trending such as machine learning and deep learning. So there, these kinds of sections are all we can use for this image processing. Okay, so for this we have to do some of the techniques, and for that particular thing only here we have introduced the MATLAB tool. Therefore this process is known as digital processing techniques for manipulating the digital images from one form to another form. What are the technologies used for image processing means enhancement section, denoising, segmentation, compression, steganography, watermarking, image retrieval, recognition, and fusion. So by using this kind of particular sections, here we will be able to interact with each and every function. So in upcoming lessons, we will be seeing this kind of each and every simple functions as our complete requirement. What are the different types of images available? Color image, grayscale image, and binary image. So this color image, it is nothing but whatever we are currently being used, and that particular color image can be set as three planes, RGB, red, green, and blue. Combination of these three colors only, it is commonly set as color image over here. Therefore, if we go for that particular grayscale image means it can be set as variation of 0 to 255, where 0 is black and 255 is white. So in between that particular range, it is known as the gray picture. The same thing if you are going with the binary image means it has only two options, 0 and 1. So combination of 0 and 1, it is known as some sorts of mapping, which is mostly used for segmentation purpose or conversion purpose. And therefore that particular segmentation can be called as binary segmentation. So these are the examples for three types of image: the color, grayscale, and binary. What are the different types of file formats available for images like JPEG, GIF, TIFF, PNG, JPEG 2000? And now let us try how to get input of this particular image, and also how to display that particular image. So now get back to the MATLAB. So here I'm going to provide a variable a equal to imread. Imread, it is nothing but known as image reading. So within bracket I'm providing that particular file name. So the file name here I can take it as 1.jpg, and therefore the next thing I have to display that particular image. Show within bracket the respective file name. Okay, so this is nothing but to read as well as display the image. So this is the basic function. So here to display that particular image, I must have an image inside this folder. So what I'm going to do means I'm just going to download an image from Google. Any one beautiful image I'm going to take. Yeah, I hope I like this. So I'm going to save the image in the same path. I'm going to save it as the same name. Yeah, therefore the image has been saved. And here I'm going to provide as IR. Okay, so finally we have just read that particular image and we have been able to display it. Okay, so this is nothing but known as reading as well as displaying that particular image. Now, before going to that particular kinds of image process, we require some of the basic programming. So on that basic programming, we are going to start with some of the basic sections known as if condition, else condition, loop. So this kind of some basic requirements are there. So first let us start with if condition. So this is just a basic practice. So here I'm directly going to type that particular values a equal to 5 and b equal to 6. If a greater than b, display a is greater. Okay, else DASP within bracket b is greater. So now if I run this particular code, so here I have to provide an option known as end. That is the basic of the syntax. Okay, so this is nothing but the different syntax while compared to the other programming. That's why I have started with this, because after reading that image, for some of the sections we have to use this if condition and for loop, and that time it will be thinking it as new. So here there is no need of providing this particular brackets or braces over here. The same thing after that particular colon whatever we provide, it will be indenting according to the particular program. So that is most important part inside this particular functions. And for each and every conditions or the loop, end function is must, because once the end function is provided, then only the particular execution of the condition gets ended over there. Else it will be throwing out an error like this. Now similarly, let us look for the other sections like else if section. So else if is another one part. Else if a double equal to b, disp both are equal. Okay, I have to change the input value. So now I'm running it. Therefore, it has been satisfied that particular condition. So this is the most of the functions we'll be using. And I hope this particular functions will be using for your task also, for loop. So inside this, the for loop has a different syntax while compared to the other programs. There we will be having one sort of application like for initialization, condition, increment or decrement. So this is the default statement that has been provided for all the sections. But in this case, the syntax is here we will be declaring as well as assigning the condition in direct itself. So this is the complete change while compared to the previous codings and this particular coding inside the MATLAB, because this particular contains all multiple size of coding. And now I'm going to provide for the for loop for declaring directly 1 is to 5. So this 1 is to 5, it is nothing but 1 is known as the starting point and 5 is known as the ending point. So now for the iteration purpose, I'm just providing a equal to a plus 1. Now I am ending this particular loop. Okay, so from that initial value till the 10, it has been calculated, and therefore finally it has been displayed what is the last value. So therefore this is known as the for loop structure inside the MATLAB. Now let us move on towards the while loop. Yeah. So for while loop, the same kind of syntax only. There is no change of syntax inside the while loop. So while we have to provide the variable and we have to provide the satisfied condition over there. Based on the calculation, it will be provided inside the loop. So how to run means while. So now the final value of the a will be displayed. Okay. So finally, till that particular iteration, everything will be displayed. Now if you want to get the continuous data over there, okay, so this is nothing but the continuous data from 6 to 15. So if we want to get the same data, sorry, so this is nothing but the continuous data over here if we provide it as 1. Okay, so this is known as the while loop statement inside the MATLAB. So how to load a image inside that particular GUI means, again we have to create a GUI function. So first I am providing the button and also I am taking the access. So both of them are ready now. Now let us edit the property and I am clicking on load. Okay, and therefore this is the push button 2 as the tag. Now let us just execute it. So here I am going to provide the data like imread 1.jpg. So I have given that both displays over here. Now I have to set that particular access handles.access 1 comma b. Okay, so now therefore it will be able to load that complete data over here. Yeah, this is nothing but due to my MATLAB problems only. So that's why it is displaying that complete error. So this is known as that complete sections where we have applied this complete function over there. And finally, it has been displayed that particular image exactly within this complete access whatever we have shown. Or we can also create this method. Okay, so both the ways it will be able to just display that particular section inside the GUI. So this is known as loading the image into the GUI using button as well as access handles. Just type imshow.a and below that provide the access handle loaded. Okay, so now let us move for our another state known as filters. So filters are nothing but to smoothen the image or to apply some of the changes. For example, if you are taking any of the image and if you are facing any of the issues with your cameras or any other images like noises or unwanted sections, so this kind of functions can be easily called as the unwanted parts or the noise of the image. So to remove that part of sections, we can use the format known as filters. So inside the image, we have many kinds of filters like removing or compressing the complete data or taking only the outline of a particular image, which is known as edge reduction, and the median filter, which you might have heard most of the digital signal processing part. That particular filter it is used to remove the salt and pepper noise, and at the same time we can also create some of the noises for our testing purpose inside the images. So this and all particularly known as the filter section, which takes in the form of matrix value and with some of the iteration purpose as well as this function defaultly provided inside the computer vision toolbox, we will be able to access those filters as well as generate some noises. Okay, so here we have two sides. One is for generating the noises, and to remove the noise also we can use this filters over there. And by using this filters, some of the sections like color conversion and removing that particular unwanted part or combining two images and detecting some parts of segmentation, everything can be applied. The images. So this is one of the color image, brain image, another color image. Okay, so these are some of the images today we are going to apply over here. So from that, two images you might have seen. One is this one. So this is not required. Another one, this is also not required. Okay, so this with the help of this already I have got into the particular MATLAB. So for first, let us see how to load that particular image and how to save that particular image over here. So here I have a particular image like this is a basic loading of value which we have seen initially. So first I am doing that im read in order to read that image and displaying that image using im show, and after that to display the details like the whose command. So for that only here we have provided this particular function, and after that whatever the image that has been read we are renaming it and saving over here itself. So this is known as imWrite. We are calling the write function and therefore providing the name in which name it has to be written. So previously I have done and that particular image has been stored over here. So for your reference I am just deleting it. Now I am running the code. So this will be that particular image and that image has been saved over here. Now if we get back into the so therefore that particular image is there, and similarly will also show with any other image. Whenever we are providing the image as input, the most important thing is the format and its name. That is the most important thing. Now here I have given into the 1.jpg and it is getting converted into a.png. Okay, so therefore it has been converted. Can also be said as overwritten. So in this way also the format conversion also can be done using this imWrite function. So this is used in multiple places on the basis of image uploading or image processing sections to change out that particular format. So this is an basic application, and here we can see that particular whose. The size of the image 768 into 1024 into 3. So the depth of the image is 3, length into head, length into breadth, it is 768 into 1024. So this is known as the basic image reading as well as writing. Yesterday we have seen only reading and that particular reading inside the GUI. Now next. So here we are going to see how to get an input image, and after that how that particular image will be converted into the grayscale and how to flip that particular image in different axes. So first I am providing CLC clear all close all to clear all the previous data. I am read the respective image to be read. I am show for original image, which is known as the RGB. To convert an image into grayscale, it is very simple in MATLAB. You have to use only this command RGB to gray, and within bracket the parameter which you have to convert it. So therefore here we have provided as a as the variable, and that variable only here we have done as the call, and therefore now the conversion will be done and the converted image will be stored in B. Finally I am show B and therefore displaying the gray image. Now how to flip that particular image? So here the variable has been provided as horizontal. Flip dimension is the command. So within that, which image you are going to flip means the image which contains color or the original image, comma 1. If you provide it as 1 means the horizontal flip will be taken place. Okay. The same thing for vertical. If you click, if you provide the image, comma 2, vertical flip. So now I'm just going to execute. So vertical flip image, it has also been placed over here. But the thing is, some additional figure also has been displayed. So this is vertically flipped, horizontally flipped, grayscale, and the original image. So now everything is in orange. You guys will be feeling a little bit difficult to find out the flippings. So now I will just change the image. Okay, so figure 4. So this is grayscale and this is the original. So check this original as well as the final image. So you can see the neck of this particular penguin, how the direction has been changed vertically, and therefore the other thing. So this is horizontal flipping. So now it is clear that how that functions are done. And this is the way we will be converting an image into the grayscale. Here we have two different kinds of bit plane separation. So how to separate that particular bit planes? Bit planes are nothing but known as the plane separation. So here inside an image we have three different colors known as RGB. So how to separate the three colors and recombine it? Okay. So now here I will be taking one image. I will be taking a color image. Let us take that penguin image itself. So that particular image will be taken as input section. After that particular input section, here we have to declare the three planes for different colors. So first one for RC is known as red color, red channel, G for green, and BC for blue. So this particular thing, here we have to declare their separations. Okay, so generally whenever you are working inside the image processing, the most important thing is to know that RGB. Okay, so whenever we are just going for this kind of variable declarations or finding out the positions, so therefore the first position stands for R, second position for G, and third position for B. So based on that only we will be splitting the colors like 255, 255, 255. So this is the common separation of the colors inside the RGB section. But here we are going to separate the plane from a total based of sections like multiple different colors of a particular image, and from there we are going to separate only single plane over there which contains a complete combination. So that particular combination only here it is applied. So for that here we have to apply that particular variable, and for that particular variable we have to convert into the matrix form. Okay, that's why only here for red color, to take the first position, here we have given it as third order. Then for green color, the third order itself second, like RGB, and for blue it will be taking it as third order. Now these particular data we have to apply with the matrix section. So here zeros, it is nothing but the matrix point, and the matrix point itself, here we are deciding the size. So size of the variable for first position, second position. Okay, and the third position will be taken as unsigned integer 8. So this complete data will be in the form of unsigned integer 8, and finally we have to take this in the form of the different combinations. So how that combinations are taken, like red and cat is one of the function where the separation is done. Okay, so this particular function here we have to take the three planes. From the three planes, the first one for red, green, and blue. Okay, so here if I enter it as RC means it stands for red, and this stands for the function known as red plane separation. Then coming for the green, this is known as green plane. So here AB indicates as 0 where both the two characters will be in the form of null. So that is known as the matrix in the form of zeros. So once whenever we combine with that zeros means only this particular plane will be highlighted out of the three planes. So similarly for blue. Okay. So wherever we are extracting the exact color, so that place only here we will be calling the functions, and rest of them is combined in the form of zeros. Then how to recombine it? So for that recombining, this will be the process. Like within a single parameter, we have to apply all the colors known as RC, GC, and BC. Because these particular planes only it is being separated for different applications. Now, so the first thing it will be plotting it as red separation over there in the form of subplot. So here subplot it is little bit difficult because it will be seeing as small. So I'm taking the subplot. Once after showing you the exact output, I will show what is subplot over here. Now for what and all the images we have converted, that should be placed over here. I am show red, I am show green, I am show blue, I am show reconstruction. Okay, this is original. I mean the recombined one. Okay, so everything has been so quick. So to show that particular separate, yeah. So now everything is displayed. Okay, so this is nothing but the figure 1, which is known as the red separation alone. So from this we are separating only the red plane, and I hope everyone knows what is this particular original image. So this is nothing but the green separation, and this is nothing but the blue separation, and therefore this is nothing but recombine or known as the original image. So this is one format. So the other kind of function, it is nothing but this way also we can use it. So for same image but same process. So like here the subplot is there. So subplot is nothing but within a single window plotting the multiple images. Okay. So here we are providing that clear CLC everything, training that image. So first subplot will be pasting that particular image. So what does this particular subplot indicates means two rows, two columns, and its position. Okay. So the same thing for other kinds of subplots. Therefore, the first we have to read that particular image. After reading that, we have to declare the variable for red, green, and blue. For red, here we will be applying 2:3. This is one of the ratio. And similarly for green, 1 ratio as well as 3 ratio will be applied. And for blue, 1:2 and 2 ratio also will be applied. So based on this only, each and every subplots also will be provided. But this particular calculation is little bit complex. So better we can go for the first version of bit plane separation. But in order to show the different methods, I have chosen this. So the same result only, whatever we have. Now everyone will be having a doubt whether the scan image, whatever we are seeing like CT scan or MRI scan, so whether that image also is possible for separation. Yes, definitely. So for that, here I have a brain tumor image. Let me check what is the name of the image. Yeah, so its image name is 3. That particular image also has this features recombine blue plane. You can see it has been applied only to that image, green and red. So for all the images, this color separation is applicable. Even though that particular images are in gray color, that is also a kind of combination only, where RGB is the only application which we can see with the multiple features. So now this will be that particular result. So this is nothing but the original image. Okay, so this particular original image are like the multiple colors converted to gray, and from the gray, whenever the image is getting opened, the intensity of greater than 150, and after that how it will be there after closed. So by combining both of this, number of objects can be found. So where and all the white part, so this particular white with black combination is there, that is considered as the objects. So that particular object numbers, it is being displayed. So there are totally 7 objects over there, and this will be that particular matrix number, whatever everyone has been expected, like how the image will be reading, so how that it will be able to convert it over here. So this and all only known as that particular matrix numbers. Okay, now I will just change the value to 100 and execute the code. Now let us see how many objects are there. So there are totally 12 objects. Okay, so that particular 12 objects, it is very difficult to count in a minute sections over here. So the variation of this intensity, it is possible from 0 to 255. So when you apply for the 255, which is the maximum range of intensity, so here you have only one object. What happens if I give it for 200? We have seen for 150, 255, and now we are going to see for 200, and therefore there are 4 objects. To calculate in and 4 kinds of sections, so therefore this is known as the objects found, and this will be the intensity range. This also comes part of segmentation. So regarding the segmentation, we'll be seeing in the upcoming classes. Now what happens if we are providing this intensity level in the range of 50? Because for double digit we have to try it. So for double digit also 12 objects. If we provide it for 0, 16 objects. Now you can see the difference. Like I have set the range from 0 to 255. So that particular 0 to 255, when we are applying the 255, the number of objects was 1. But when you go for the number of objects 16, so therefore the intensity should be 0. But here it is not completely showing it as 0 objects are present. So that is nothing but the complete process of image which varies on the intensity. According to the image, the intensity variation also gets changed. But here also you can see how that particular matrix values has been changed. So how much difference will be that particular objects between the 0 as well as the single digits. So I will apply the single digits as 8. So if you apply any of the single digit, therefore it will be completely the 16. If you are going in the range of 50 to 100, number of objects will be 12. If you are going with 150 above, it will be 7. If you are going for 200 plus, it will be 4. And if you are going for 255, it will be as 1 object. So like that only the multiple objects are being segmented by using this kind of functions. Okay, so now let us move on to the function like histogram. Histogram, it is like an equalization of multiple colors present inside the image. So that particular data, whatever we are getting, it will be plotted in the form of a graph. So here we are not using any of the functions like a plot, like bar graph or like that and all, because inside histogram function itself, we have a default plot section. According to the process, whatever we see, the image also will be taken automatically over here. So as usual, we are providing all the clear data. Then we are reading that particular image, and that image is plotted in the subplot. So to see it in a different way, okay, leave it. If you go for subplot only, it will be very good. So from this particular subplot, I am displaying that particular image. After that, converting into the grayscale. Now I am going to find out the histogram equalization for a gray image. So for that, the main function is histeq. Histeq will be known as that particular function. So within that, the respective variable should be provided, and it has been provided as gray. Now, what and all the images will be displayed means, one is that particular gray and another one is the histogram. So this histogram itself, we are taking it for 3 different plots. Okay, that is for original image, gray image, and finally the histogram applied image. So here for now I am commenting it, and we are running only that particular equalization. So this is known as histogram equalized image. This is for a MRI scan image. The same thing if we go for a color image, which is similar to the grayscale. Okay, but some pixel variations and clarity will be changed. Now how to plot this particular data? Now I am running it. Okay, so these are that particular image, and here we can see the difference. For color image, this will be the equalization plot. Instead of subplot, I will just display it separately so that we can see the graph as clear as possible. Okay, so here we have 3 different sections. These are the original images. First, let us go the variation for original image. So this is that particular variation for original image histogram, which is known as into the power of 4. This is for the gray image. So that particular variation is identified over here. There it was 10 to the power of 4. Here there is no such powers, even though it is taking in 4 digits. Here the normal values are taken in the form of 10 to the power of 3. And this is nothing but the histogram data. So on this basis only the complete classification can be applied over here. This is known as histogram equalization. Sir, in histogram, plot what is x-axis and y-axis. Yeah, so this particular plot, inside this x-axis and y-axis, x-axis is known as total number of bins, like can be said as total number of pixels, etc. And this is known as the frequency of each and every pixels. The y-axis is completely known as the frequency of complete pixels. Okay, so here there is another one question. L num. Yeah, this is to count the number of labels. count the number of labels from the closed image. Okay, so the inverse of the closed image only we'll be able to calculate the label value in the form of unsigned integer 8-bit. Yeah, frequency means intensity. It is directly proportional to intensity. Like that only we can say intensity of particular image. Just I will run this code. Okay, so here just see here the subplot I have taken it as 3 comma 1 comma 1. So there are 3 rows, 1 column, and which position. So here I have given it as first position. So first position is original image 3 comma 1 comma 2. Third 3 rows, only 1 column. So on second position I have taken as the gray image. Third position as histogram image. This is known as the subplot. Fine. Okay, so let us see for the next application. Next application, it is nothing but how to combine two images into a single image. Here, first we are providing all the clearing and closing of data. The next thing, I am reading one of the image. I am reading the second image. So plotting both the images. So here I am using the new function known as IMShowPair. Okay, in this type of montage display, I will be showing it. So these are known as the original image part. Now both the images are in different size. So if both the images are in different size, then we won't be able to combine it at all. So what we have to do means we have to resize that particular image. So for that, here I am using resize function, which is known as IMResize. So within that IMResize, the first parameter, it is nothing but known as the image where we have read it, and the second parameter is known as the size of the image which we have to be converted. So here I have given that particular command as 250 comma 250. The same thing I have provided for the other image also. So RE and RE1. Now here I am going to combine both the images. The combining is done using the function known as IMAdd. So which two images I am going to combine means RE comma RE1. So that is the combination has been done, and therefore that has been plotted in another plot. So the name of that particular image, it is known as merge, which can be set as merged image. I am executing it. Okay, so this is known as that particular image. So I am show pair combining two images, and this is nothing but the merged image. So here the intensity or any of the variations, nothing has been changed over here. Okay, image enhancement. This topic, it completely deals with enhancing the number of images. Like whatever the images we provide towards the system, so that particular images here we will be able to apply that complete sort of functions. So on what basis means from moving the low quality image to high quality. Now inside this kind of applications where it is being processed means nowadays we have multiple types of softwares for editing the videos, photos, and all that 3D characters or designing the 3D everything. So this completes each and every sections are termed as image. If you take video means continuous moving frames are known as moving frames of images are known as the video. So there also we have that particular image only. So this particular image in what and all the ways that has been converted means based on the pixels. What is that pixel? So that pixel, it is nothing but a portion which we can see inside the image where a group of pixels will be called as an image. A single part or single data is known as an pixel. So by grouping that particular pixel only, here we will be able to form an image. And that image formation also should vary according to each and every display size. Currently, everyone is a consumer of digital visualization. So what are those digital visualizations? Laptop screens, PC monitor, TV, mobile phones, etc. So from this particular different digital visualization, we have to see everything clear data. Okay. So what is that particular clarity? For example, if you are taking a mobile and if you're capturing a phone, we can just start from the oldest evolution. So that particular image, if you are just seeing inside that particular screen of the mobile means it is in a good clarity. The same thing if I am taking into my PC and if I am seeing it another viewer means therefore it will be in this particular mode. So this type of clarity will be there. Okay. Now, if you are taking the photo in an updated version of the mobile, or you can say it as a DSLR camera, and after that seeing in that particular camera LCD or LED display, and we are just seeing the same view inside our particular monitor. So that is nothing but the clarity level or the balance, because wherever we see, that clarity should be maintained. Okay, so how it is getting varied over here. Now if we go into this particular kind of clarity sections, what are the different clarity ratios? Like 144, 240, 360, 480, 720, 1080, 4K. So this and all that particular different qualities. And before 4K, some displays are even working in the form of 2K. So this kind of different displays only. Here that image enhancement is required. And at the same time, if you display this highly enhanced image into a small display means you will be getting it more brighter. So this is known as the requirement of enhancement section. So the display should automatically enhance according to the feature. Okay, for example, if you are recording a 4K video and if you are just going and playing it in a 1080 pixels TV, like a full HD TV, it never plays. The reason is whatever the 4K which we have taken, 4K means it is for 4000 resolutions are there. That particular resolution pixels have around of 4000. So that particular 4000, it is nothing but each and every boxes will be there. So once whenever you are compressing, trying to compress into a TV means 1080 pixels TV, therefore that compression process also will be taking, so that some of the processor will automatically starts to get heat up over there. Like it has to compress and at the same time it has to run this video. So this is double time the work. If you are giving an actual procedure inside to that particular display means, therefore it is equal to that particular processor, and therefore it will be automatically executing that video without any interference. Whatever we are facing the interference inside the YouTube, it is completely different. That cannot be related towards this particular TV, because all the display or visualization, it is controlled through cloud by YouTube. But here if you directly plug in that particular 4K video into the TV means the USB doesn't have that much kind of support. Or more than that, if you want to just play it in means you have to connect it through any of your HDMI connections. Then only it will be able to enable. So this is nothing but the difference between the enhancement sections or that resolution sections for an image or video over here. Because according to that 4K video, the audio is also in that much amount of high clarity. That is the main reason for many of them are just trying to work out over here. And definitely why this particular image enhancement is used in image processing means for training purpose in machine learning and deep learning. Here we won't be able to directly implement that 4K image, 1080 image or 720 image for training purpose. So we have to resize the size of that particular image, remove that particular pixels. After that we will be converting into the grayscale. So from that only here we will be able to train that particular image in the binary language. Then only the machines will be encoded into its weights file or CFG file, anything. On this particular basis only the image enhancement portions are required for image processing purpose. So inside this image enhancement, what and all here we'll be using, like contrast enhancement, spatial filtering, density slicing, fuzzy clustering. So this and all some sort of applications which we will be seeing. Like yesterday we have seen some of the fusion techniques. So inside that fusion is how that image has been fused, and from that particular fusion, like how we will be able to take only that particular portion over there, how to resize a particular image by using IM resize section. So this and all known as some parts of processing technique. So this and all includes inside the processing part. And same way, if we go for this particular image enhancement sections or image dehancement, so enhancement and dehancement means like increasing and decreasing only. So that particular enhancing part, it is from low clarity to high clarity. So if that particular video is capable of it, definitely we will be able to enhance it by removing its blurriness or changing its complete, how to say, like its parameters. The same thing if you want to dehance means it is also possible by removing the number of pixels. And nowadays I won't use any of the particular direct kind of softwares for this. In case if I want to download any of the 240 pixels video I have already that particular online compiler. There are some of the online free compilers for that. Like if you just go into that website, we have to drop their video, we have to select the resolution, and if you give OK, they will convert it and we can download it. So I need to no need to install any of the softwares over here. So with that particular software, the video size is also compressed over there. So this kind of functions and all can be sent as image enhancement and dehancement sections, erosion and dilation. So generally, that particular erosion, it is commonly said as removing the number of pixels. So erosion, that particular word also we might have heard, like soil erosion. So that particular soil erosion means the soils are moving apart from a particular place. So like a natural disaster. The same erosion technique here we are using to dehance a pixel. After dehancing, if that particular picture is viewable to you, that is one sort of application over there. So that image, you will be able to take it up to many kinds of functions, like uploading it in some parts. For example, if you're going for some of the other than machine learning and deep learning, like augmented reality trainings and all means, this image portion should be compressed. And many of them might have seen whenever you are just going to that government portals, if you are trying to upload your photo and there will be the required size. So this must be the size to upload your photo. So this and all, it is done by the process of erosion. But whenever we are using that particular techniques and all inside the software, there the erosion technique is not highlighted. If you just ask to that person who is designing in Photoshop, like reduce the pixel or reduce the size, increase the brightness, like that and all, if you say means, he will be just adding that particular required things, and for each and everything, a scale variation will be there. Erosion, it is one of the type of image processing which is used for image enhancement section. So this particular process, it can be said as morphological operations, like to remove the number of pixels from a particular image by using the lattice function, and at the same time, this can be removed for both gray image as well as the color image. But 90 percentage, everyone will be using this kind of process for gray images only, this erosion and dilation. For color images nowadays, they have found the technique as like removing the brightness or moving the scale variations inside the Photoshop itself they have. Now, dilation. Dilation is other part of this morphological technique which expands the image based on the pixels. So if you add that particular number of pixels means, according to that, the pixels orientation also gets changed over here. But here we are doing only the process for that particular size. For that increasing or decreasing, those kind of sections and all, it can be done only with the help of some of the implementation inside a filters or processes, depending upon that. As we are doing the simulation parts of this image processing, only that pixels are added or pixels are removed, those portions can be checked. If the pixels are added at the maximum range, the complete image will be white. If the pixels are removed for the complete or the maximum range, therefore it will be in black. So this is only that particular process of erosion as well as dilation. Now let us get into the code. So here the same clear and just I have given the comment as morphology, clear screen, everything is being provided. To see this particular image in a good manner, I'm just using IM show. I'm not using any of the subplots. To provide that erosion and dilation, it is very simple. First, we are providing the IM read, then IM show. This will be known as the original image, and converting into the grayscale. So this is for background subtraction, like yesterday, whatever we have seen. So after grayscale, that binary sections will be provided over here. So from that particular binary only, here we will be able to separate the background. Now, how to dilate that particular image means the same gray image we are taking, and after that, I am providing the function named IMDilate. So by using this IMDilate, therefore, from that particular background subtraction, the value is provided, and therefore the dilation gets applied, which expands the amount of pixels. The same thing if you go for IMError, same value only, which is known as the ratio. So this particular ratio only, here we will be applying it for contraction. So this separation value only, here we will be able to take as a complete sections over here. But this black and white conversion, it is completely different. And finally, by using IM show, we are displaying all the images. So now I am running it, and therefore the process has been completed and the image has been displayed. So here only the last image has been displayed. Okay, so this is the original image which has been converted into the grayscale, and this is known as the dilated part and this is known as the eroded part on the same ratio. Now if I want to change that particular ratio here, I can change that particular line variations to 0, 30. Now I am running it again. Now you can see since that particular ratio has been changed, so therefore everything has returned to its fully evaded and fully applied. Now I am changing only that erosion part. Now I am changing it to 70. So this erosion and iteration, it normally takes in the form of iteration process. So continuously the pixels will be removed. So this will be that particular intensity variations. So you guys can see now how that particular erosion and dilation is done. Okay, only slight changes only there if we are just changing that parameters. Okay, so this makes the exact color over here. Now what happens if I apply the same morphology technique for color image? So instead of gray, I am changing it as VAR. So this is the process of erosion and dilation. So now I am just changing the image. Okay, so this comes under the eroded and this comes under the dilated. So you can see how that pixels has been enhanced over here, and here how that particular pixels has been removed well compared to the original one. Original one you can see, even though after zooming only this much portion we are able to see like this, but these are not like which we have seen now. For a normal zoom itself, these many pixels we are able to see, or these many errors we are able to see. This is the other part of eroded one inside the color image. So to blur the image, we have to just read all that particular image as input, and within that we will be providing a fs special. So here I am going to provide first all the commands. So now I am going to read an image. I am read within bracket respective image name. So here I am going to take 1.jpg. I am going to give another one variable and fs special. F special, it is nothing but function special. So within this function only, here we have some sort of applications like Gaussian, motion, Sobel. So there are many functions. Here first we have to provide that particular kind of function, and from that here we have to provide the required radius. Okay, so that is that complete section used inside the function. So now I am taking the particular section as disk. So this is one type of blur, and the radius I'm going to provide it is like first we can start with 2, then we can change the radius, and these two particular data whatever we have taken, it should be combined at some place. So here I am taking the filter over here, filter. So here I am going to apply those two variables, and finally by using I am sure I'm going to display it. So where that particular filter is applied, there only here we can see this image. So first I have to save. So for 2 radius, this is not that much blurred over here. Let us change into 5. Yeah, some smoothing has happened. Let me provide the 7. So some more, the image has been smoothened. I'm providing 9. Yeah, now I'm able to see whenever I remove my specs, it is almost like this. What happens if you provide in double digit? It is taking too much time to process that. And here, what will be the maximum? So to take the radius of 255, it is taking too much time. So this method, it is known as disk type of blurring, and this is the fully blurred image over here when I have applied the 255. And definitely 255 is not the starting of blurring. I think before itself it might have started in this particular process. Okay, so now let us try to change this type of blur. You can type Gaussian blur, and I will provide 5 itself. Yeah, now this is looking normal. So here disk. So for this particular disk, I am providing the basic as 2, and therefore only slight smoothing is there. For 5, this will be the smoothing. I give for 19, this will be the smoothing. For 255, this will be the smoothing. So for 255, it takes a lot of time as I have given more number of iterations for blurring. Yeah, still it has not displayed because it takes more time. So this is the output of 255. So this is the maximum range. Even more than this also can be provided. So let me reduce into 100. Yeah, so here I am able to see some things. While compared to the 100 and 255, 100 is better. I'm reducing it to 50. Yeah, far better. So 19 and 20, 19 or 20, it will be like this. If I am reducing it to 5, so this will be a normal smoothening. And if I am providing it to 2, this will be that original smoothened image. Now, similar to this, I can change it to Gaussian, which is another type of blur, and I'm providing the radius of 50. Okay, so here I would like to take Privet as one of my blur. So for Gaussian, it doesn't take place with any of the changes. So this is another type of technique. Whereas if I want to go with Gaussian means I have to provide the H size. H size, it is nothing but known as the image size or that particular pixel size, and also the sigma value. So like that, total 3 parameters must be there, and this is known as the Gaussian blur. This is one sort of application. So here I am reducing the H size. Let the sigma value be the same, and therefore the smoothen has been reduced. Let me provide both H size and sigma value as same. Yeah, what happens if the sigma value is 100? Okay, so that blurriness, only slight changes are there if the sigma values is changed. Whereas if that H size parameter is being changed means there will be a drastic change over here. So this is the way here we have to apply it for Gaussian blur. So image blurring and deblurring, it completely gets only on this basis. Now let us try with an blurred image. Okay, so for that, here I am going to take the same thing. I am right. I am going to save that particular image, and from that image itself, I am going to upload it. Okay, so bl.jpg is ready. Now I am erasing this. So here I am going to provide it as 1 on the sigma of 10. What happens to this particular image? So therefore, whatever the image that has been stored in that particular range, that only it will be displaying. Let me change this into disk, comma 2. So this will be the same way of setting inside that particular section. So by this, we came to know that this set of code, it is used to blur the image only. So how to deblur a particular kind of image, that thing only now we are going to see. So now whatever we have applied, it is for a normal kind of section. So inside this particular kind of function itself, we have one more example from this MATLAB. So now we are going to apply the deblur. So this particular deblur will be applied for the purpose of removing that particular kind of blur section. For that, here I am going to take the same kind of image which is known as cameraman.tiff. So here the original image will be provided, and here we are providing some of the filters for blurring that particular image, the same F special but in a different kind of section known as motion blur. So from that, here we are going to apply the restoration by using convolution. Convolution in the presence of winner image deblurring method. So by using that particular section only, here we are going to apply. So is this is applicable for the previous one also means? Yes, it is possible. So how means? Just we require this particular WNR1 command. So we have to change that particular variables whatever we have provided. So here for D, C, D. Okay, since we have applied the Gaussian blur, it will be in this state. In case if you are going with the same motion blur means, we will be able to receive the same kind of output. Okay, so now let us run this particular section. So here, this is nothing but the blurred image over here. Now that particular blurred image has been restored. So like if you are using this particular blur section for motion means, this is the function for removing the blur. Okay, so due to that MathWorks problem, I am not able to access the function named len over here because it is defaultly available over here in the variable. Yeah, so MathWorks is not allowing that particular sections inside this example part. Okay, so in this way only I will be able to just show the simulation blur. So for the simulation blur, you can go with this particular command. So this will be the command which we can use to open the deblurring option inside the MathWorks. I will post this command in the chat. You guys can try it. There are many permissions which we have to convert over here to get any of the some functions from MathWorks. So once again, I will explain this part. So here I am going to simulate a motion blur section. First, the image will be read. in the form of double data. So from that, whatever the image we are just taking, therefore it should be converted into the length across the pixels according to the degree. Okay, so for that, length as well as degree is taken. So this is in case of motion blur, we need the length as well as degree, like which we have seen for Gaussian one, which required the h size as well as sigma. The same way only the motion also will be working. So therefore, this particular motion section here we are applying it, and by using the IM filter, we are calling this particular motion section convolution and circular mode. So this kinds of mode, it is defaultly available through this particular MathWorks package. So from here, we are just displaying the blurred image. Now, by using the deconvolution section, which is known as Weiner image deblurring technique. So by providing that particular application, here we are removing that particular blurred section, and therefore the image is being restored. So noise, generally the noise is nothing but known as the unwanted signals or unwanted requirements of a specific function. If we go for many kinds of process, for everything the noises are there. If you go for electronics or working with embedded, there are many noises over there. And to remove that noise, we will be using some of the capacitor based circuits. If you go for some electronics based systems, there also the noise will be there, which is called as harmonics. And here inside the image processing also, we have that exact noise. So by use, what is that particular problem, especially inside the images, means the image quality will be lost over there. Whereas if you compare that particular hardware as well as this image, means inside that particular hardware, we will be able to at least filter out that particular values. But here inside this particular image, means it will be losing its entire quality. So that is a major drawback on this particular noise. So there are many reasons for the noise. Maybe whatever the device you have used for capturing, there will be some interruptions, and whatever that particular kinds of processor inside the system will be generating some noise. Or if you are not providing some kind of adaptive locations or adaptive transformations whenever the image is being captured, so there are many chances of noise. Even for some of the places, you will also gets affected based on some of the environment sound. So regarding that also, some of the noise problems will be there. Okay, most of the noise, around 80 percentage, the reason for noise, it is nothing but the image sensor or the camera. Even if you are using a scanner, there are chances to be getting some of the noise and all. So that is completely nothing but regarding towards that exact hardware. Okay, whichever the scans the device or whichever it is used to collect the data. So whatever the hardware which we are going for, that only will be measuring major causes for the noises. Okay, so now let's check how the noises can be generated. Previous session we have seen how the blurring can be done. Now we are going to see how the noise can be generated over here. Okay, so here I have some different noise. Let us see one by one each. Okay, so first I am going to read that particular image. The image is nothing but 4.jpg. Let us see what is that image whichever we are using. So this is just a brain. I mean the scan image of a brain. So now I am just providing that input image, and that image also will be displayed. And for that particular image, I am going to provide the noise as the input. So here I am going to provide the Gaussian noise over here. So this Gaussian noise, it is nothing but yesterday or regarding that blur, the same theory of Gaussian application only. Here we have to apply the sigma as well as the head size of the image. So according to that particular image as well as the head size, here we will be able to collect that complete data. So from that particular sections only, the entire noise selections or the kind of applications, whatever we check it over there. So based on that particular kinds of functions only, the noise will be implemented. So this particular section here, we are going to create IM noise. That will be the exact function. And from that particular exact function, therefore, we have to create it in the form of the variable. So that will be the first parameter for which image which you are going to read. Then we will be creating that particular variable. So for that, which type of noise? If you are going to provide Gaussian, then Gaussian will be applied. And after that, we have to apply the ratio of the noise which has to be provided to the image. Okay. So therefore 0.1, 0.1. And after that, this particular noise will be displayed over here. So in MATLAB, it is very simple. So now I am just going to run that. Okay, so this is nothing but known as the Gaussian noise. Moreover, all the noises will be looking same only. So this is the original image and this is the noise applied image. Now I will just change this value over here. I'm giving it as 7 ratio of 6. So now the noise ratio has been increased. So this is the way we will be just applying the noises. Now how this particular thing we will be able to upload into a color image. So whatever I have just shown, it is a scan image which contains the color but not exactly. Okay, so this is the noise that has been applied for a color image and I will reduce its value to 3:3. Okay, so in this particular way only here we will be able to add the noise. So this is for RGB noise. Now in case if we want to add the noise for the grayscale image means, okay, so here I am getting converted this particular image into grayscale. Now inside that noise section I have to call that variable. Okay, so now everything is fine. Let us run it. Yeah, so this is the color and this is the noise applied to the grayscale. If we provide 0 to this particular ratio, therefore the noises won't be applied. Now it is an actual gray image. Whereas if I am changing into slight variation, like let this particular ratio be of 9, so therefore amount of noise is added. The same thing if I change the ratio onto the left hand side, like vice versa. Okay, so this will be that particular blurriness that has been added or removing the white surface over here. So by combining these two only, here we can say it as the process of Gaussian noise, and this will be the required format to apply the Gaussian noise inside the image processing. So now let us move to the next. The next noise is local variable noise. This is similar to all the noises are almost same, only their parameters as well as their implementations gets varied. So here I am going to take the direct section of input image. So first let us see for how the noise is getting applied for the color. And here we have to apply the local variables in the form of the ones value. So during the initial image processing section, you might have seen taking the values in the form of matrix such as ones, i's, and zeros. So this kind of sections only here we can see. From that we are taking the ones because whatever the data we are going to apply for the local variable sections, this will be 256. We can also change this value, no issues at all. So this particular IM noise, and we have to provide the name as local var, and the additional parameter, it is nothing but ones value. Okay, so here it is not able to support that color image because the local variable is having only the variations from 0 to 255. Okay, so here there is an issue with the noise and definitely we'll be recorrecting it. The next we can move on to the Poisson noise. So Poisson noise, the implementation whichever we are providing, it will be in a high level manner while compared to the Gaussian noise. This doesn't have any of the additional parameter to point out over there. So we can directly implement it. The syntax is IM noise where within quotes Poisson. So Poisson is the keyword and therefore everyone can see by comparing these two images. So this is completely clear and here we have some range of noise and this noise value cannot be changed at any cost. Now let us apply the same section for grayscale image. Okay, so here we can see some slight differences while compared to the color regions. So these are known as the noise parts. So here there is no such kind of differentiation. Here we can see. So this is the method of implementation in Poisson noise. The very simplest noise which we can work on it. Next, we are going to see salt and pepper noise. This is the most available noises while compared to everything. For example, if you take any of the CT scans, MRI scans, or any other images, the most occurred noises are known as salt and pepper noise. And this is also very easy to apply. So here IM noise, the particular image which we have to provide input, then the salt and pepper. So this particular is known as the keyword, and therefore this is the ratio of the noise. So here we have to apply only the single ratio for the total image, and therefore the noise gets applied over here. So let us start from point 1, then only the variation we will be able to understand. Okay, so for salt and pepper noise, this is the minimum level. While compared to Gaussian, it is little bit less, but this is little bit powerful. And for this only, we will be applying most of the median filters. Now let us vary the value. I'm just varying only slightly for zero point 0.4. So based on the point itself, you guys will come to know how that variation is being applied. Now the same thing, let us try it for the grayscale images. So on point 1, this will be the respective output for it. Now the same thing, if I change for point 4, the same value, this will be the noise applied. Rather than applying it for a color image, we will be able to see a major difference inside the grayscale images. Like in previous images, we will be able to just check this kind of sections and all. And this is mostly applied for CT scans or MRI scans, like that kind of devices only, because whatever the device the noise is being generated means inside the scanning part or that particular module, which is known as image sensor, those image sensor is connected with the help of an antenna which generates a frequency of band. So that particular bandwidth or the frequency, whenever it is generating the resonance, definitely some of the unwanted signals will be there. And from that only they are able to obtain this kind of different scan images. That's why whenever we are applying for biomedical kinds of sections, especially in neural networks, we will do this image processing by removing the noise, and from that noise removal only they will be able to extract the features. Definitely there will be a particular variation while compared to the noise based feature and noise without feature. Sorry, without noise feature. Okay. For this kind of doubt, it is nothing but RGB. It is a kind of color variations. So this combined colors will be reducing that particular white or black spots inside that particular image. Normally, it is like throwing out salt inside an image only on any of the objects. So if you are throwing the salt on a color object, you guys won't be able to see that salt as high as possible. If you are sawing it, throwing it to a black and white or pure black means, then you may know that particular difference. So the same thing only over here. Inside the RGB, the white and all, it is very difficult to find out the white spots. Same thing if you go for a gray image means it is very easy to spot out that area. Okay. So next we can move on towards speckle noise. Now we are going to see the speckle noise. This is also similar to the salt and pepper noise only. The same mode of implementation. So now I have added that particular speckle noise into the color image. So while compared to the salt and pepper noise, it is not able to see inside a color that much highlighted one. But here the brightness of that particular image also gets reduced, and at the same time the noise similar to the salt and pepper also will be added. So when that brightness is reduced, this particular noise will be highlighted over here. So that is one of the major difference between the speckle noise as well as salt and pepper. Now the same noise, if we apply it in a gray image means, so this will be the type of noise. So here it is not like throwing a particular salt on it. There you will be having the white spores. Here it is completely with the black pores. So that is that a complete difference we will be able to analyze whenever we are comparing the RGB and the grayscale images with multiple section of noise. So now this particular variations also can be done. Let us check for point 1, because now we have seen for highest variation. So for point 1 also it is almost in a high oriented range only. Okay, so these are the different noises available over here. Now let me display all the noise. So first let us go over Gaussian, Poisson, salt and pepper, and speckle. So let us provide a bigger display for everyone so that we can see all the outputs in a single view. So speckle noise, I hope this is salt and pepper, Gaussian. Okay, so these are the different noises available inside an image processing. So noise removal are also known as the filters, which remove the unwanted parts, and we will be able to smoothen that particular process inside the image. Because definitely if any of the images are affected with the help of noise, it is not possible to remove that particular and reconstruct that particular image through the image processing technique. So for that only here we can say it as noise removal, and this is one part of smoothing that particular images. The smoothing process mostly will take effect only in grayscale images, and it cannot be mostly applied for the RGB based image. The reason is smoothing the grayscale images means it is very easy to smooth because it has only two sections of combination. Whereas if we go for RGB means there are multiple sections like RGB, and if you just combine each and every color means some more sections also will be introduced. So therefore it will be a little bit complicated while compared to the grayscale image. Now here first we are going to see the filter for a Gaussian based section, which is known as Gaussian filter. So now here I have an image known as, okay, so here that image is not there. Anyway, I will create a Gaussian image over here. Yeah, that's sure. So here I am creating a Gaussian noise. Yeah, so therefore the image has been created. So here is that particular image, and here I am going to read that particular image. Okay, so the noise was not properly applied. Point 1 with point 1. Yeah, so now the image has been created. Now let us see that particular filter. Oh, again I am running the same thing. So while comparing to that right and left image, so you can see only some variations that has been applied over here. So this is nothing but the Gaussian filter. The Gaussian filter, it is commonly known as the Gaussian blur. So by using that blurring technique only, everyone will be changing their particular kinds of noises into a denoising section. Blurring and deblurring is completely different. Noising and denoising. The denoising mostly it is applied based on the blur sections only. So this is just an implementation of Gaussian filter and Gaussian blur. So next we can see how to apply it for salt and pepper noise by using the median section. So for median, here we have created the same thing only and commenting the rest of the parts. So this is the part of salt and pepper. I am sure. Then bracket off. Okay. So here I have to read the noise image. Now let us see how the changes applied for. Yeah. So now you can see how much that particular ratio of noises has been reduced. So this is nothing but known as the median filter, which is applied for salt and pepper noise. Okay. So for the point 1 variation, point 1 applied noise means we can get a clear image. So on which point we are losing our section means, I hope it may be from point 3. Yeah. So from point 3 only we will be losing that particular kinds of clarity. But anyway, it will reconstruct as maximum as possible. Now let us try the same for color image. So here for color image, it is not accepted. The reason is it should be always the 2 dimension, because when we go for the grayscale, only the dimensions between 0 to 258 is applied. The same thing if you are going for an color means RGB, 0 to 255, 0 to 255, 0 to 255. So this will be that particular variation, and therefore we will be occurring an error over here. Okay, now let us get back to the gray and let us try the same median filter with other filters. For that, we are taking this line alone, and let us start with the Gaussian itself. Even though we have seen the Gaussian blur, so here I have to add it as G-Noi. Okay, so here we no need. Yeah, so everything is same. Okay, I did not add that IM noise, IM show. So for Gaussian noise also it is not applicable. The reason, here we have 2 different parameters. Okay, now let us go to the Poisson noise, because almost the Poisson as well as speckle, everything is same over here. Image compression. Image compression, it is nothing but it is a part of process to reduce the size of the image according to the storage. So here we have many types of image storage, like in the form of the formats JPG, JPEG, .bmp, or known as bitmap. So this kind of different formats has each and every size of storage according to the person whoever captures the photo. Once whenever we take that respected camera like DSLR or a high clarity 4K cameras, so all the resolutions will be high, and each and every variation of the resolutions will be changed according to the different formats. Let it be for mobile camera, if you're taking photo it will be in PNG. At the same time there are options for JPG also, some of the mobile cameras. Most of the DSLRs will be storing the data in PNG, and if you are taking screenshot from your system, that is stored in PNG. And if you're just using that particular DSLRs in high quality means they will be using JPEG. And at the same time, if you are recording a video in that means they will be providing MKV. So these are all different types of formats, and this format will be varying each and every types of quality or the size. For example, JPG is little bit high of the quality over here. So from that particular high quality, if we want to compress that particular section means, therefore we will be able to compress that complete size alone. So what they will do means many of them will try to zip that particular file, and they will be sending it to the mail. Or at the same time, they will be uploading that image directly towards the mail or through the Google Drive, and they can share it to avoid the losses. The same image, if they are sending through WhatsApp means, it will be reducing its clarity. Definitely, it will be reducing its clarity, and after reduction only the receiver will be able to see that particular image. So this kind of functions can be set as the image compressions. So this our main motto whenever we work on this image compression means, we have to focus compression without the losses. Okay, so on that particular sections, there are two types of image compression known as lossless compression and lossy compression. From that, lossless compression, whenever we are working regarding towards this lossless compression, the main motto is nothing but whenever we are converting into any format, let it be for any format, the image quality should not be lost over there. And at the same time, the weightage or the size of the image should be reduced. For example, from 100 KB to 50 KB, it has to be reduced, but there should not be any loss in its quality. And what is that particular quality? Either it may be 240 pixels, 720 pixels, or 1080 pixels. If you are converting a 1080 pixels into 500 KB means, from 800 to 500 KB means, therefore that image still should be in 1080 pixels. It should not reduce to 240 pixels over there. For example, whatever that particular compression we are seeing in the YouTube or any other video streaming inside our web pages like Amazon or Netflix, like that and all, they automatically will be switched according to the network speed. Once they have reduced or converted the pixels means, therefore that is completely a lossy compression. The same thing if we are just seeing the same view in any speed of network, even though the compression, the size has been reduced or whatever it has been done, that is known as lossless compression over here. So this lossless compression, they have been generally used to reconstruct the data or tolerate any of the difference between original as well as the reconstructed data. There should be just any differences. For example, we can say scanning the paper. If you are taking a black and white paper which you have printed, that will be the original document of your system or whatever that application. Okay, so after that, if you use the scanner and if you take the particular thing, then again if you are taking printout means both will be looking same. So that is commonly said as lossless compression. The compression which does not create any kinds of difference between original as well as the reconstructed data, that comes under the lossless compression. So how the lossless compression can be applied into the MATLAB for image processing purpose. Okay, so this will be our set of code. So now here completely it is created in the form of GUI. After taking that particular GUI, first we have to provide the input image with the help of the push button. And after providing that input image over there, it will be taking any form of image, BMP, JPG, PNG, anything. So after that, file info will be printed. So the name of the file, the size of the file is most important. Okay, and therefore their particular parent image also will be displayed over there. In my particular GUI, it is not able to display it properly. So after that, here we have to create another one particular push button to reduce the size. So for that, here first we are calling our double section, because whatever the image we have read previously, that image should be converted into the double data. So from the double data, here we will be applying the DCT matrix. DCT means discrete cosine transform, which comes under the functions of lossless compression. So from that particular lossless compression, or to reconstruct an image, a flopped image, here we will be using this discrete cosine matrix, and from that, here we have to block the process. Okay, so whatever that particular discrete matrix, it will be stored in the T, and the block process will be enabled. So this will be the matrix size. So this is nothing but that particular conversions. Okay, P1 into P2, it is named as that particular variable. There is no such function over here. So from that block process, here we will be taking for that particular respective matrix 8, 8. So that is nothing but T, T. slash. So T slash, it is nothing but the matrix inverse. Okay, the transpose section. So for the transpose only, here we are taking the data because all the DCT values are taken in the form of matrix. And this will be the masking value to maintain that particular image in the same compression. Okay, and after that, here we are taking the next stage of block process, and from that, here we will be adding the mask towards it. Now, inside the second iteration part, here we have to create the block process once again. And like this, here we will be creating the three different sections. What is the purpose of creating the three sections means? Because whenever we are creating that particular conversion of image into double format, definitely the losses will be there. Okay. So before going into that particular losses section, here we have to mask the image with multiple layer where that particular layer will be stopped or will be eroded, like an protection stage. So from that protection stage only, here we are able to maintain the clarity of that particular converted image. Okay, so finally we are calling all the variables into the concatenation part, and therefore all the masking layers and the iterations will be covering up that particular image. Once after conversion, the image will be stored into my folder, and therefore that particular compressed image, all the data will be displayed over here. So this is known as lossless image compression. So here I am taking select an image. Once again I will run. So this is known as a lossless image compression. Select the image. Okay, after selecting the image, here everyone can see the size of the image. Now compress the image. Let us wait till that particular compression happens. Yeah, so therefore the image has been compressed into 97 KB. Now let us go and check in that particular folder. So this is the original image and this is the compressed image. So now we can just compare and see. Okay, so this, therefore any of the resolutions or anything they have not compressed, only the size has been compressed over here. Lossy compression. This is nothing but whenever we are compressing that particular image size, therefore the quality of the image also gets lost. The thing is, the perfect example I can say, it is nothing but our YouTube or any of the Prime videos or any movie watching streamers. Once the network gets deflected, they will try to reduce the size of that particular display over there or that particular streaming. That's why only from HD they will be just converting into the SD. This is known as 480 pixels, and from that, whenever we just go for this kind of compressions, all the clarity video will be converted into box, which is known as the pixels. So if you are just using any of the 1080 pixel display or 4K display means, you won't be able to clearly view that. If your display is for 240 means, then you will be able to view that particular 240 converted one. So this types of conversions only, here we can say it as lossy compressions. So this particular lossy compressions, they are mostly used to compress multimedia data, audio, video and images, especially for internet or whatever they are sharing that particular images like WhatsApp, even whatever the things you are talking. So this and all comes under the lossy compression. Even for machine learning and deep learning also, they will be using this lossy compression in the form of wavelet transforms. So that particular wavelet transforms are known as discrete wavelet transform and cosine wavelet transform. Okay, so now let us see what is that particular discrete wavelet transform. Okay, so here we are going to compress that particular image using discrete wavelet transform, and everyone is aware of that particular discrete word or discrete wavelet transform. So this particular thing, it is nothing but applied in signal processing for compression purpose. So here what type of signal we are going to compress, it is nothing but the image. So by providing that CD input, the file path where the code has been stored, that is known as the file path, it will be reading all this type of images, and I have to pick an image from that, and that image will be displayed. Now that image I will be resizing it into 256, 256 in order to compress it as easy as possible. So that particular image therefore will be converted into the grayscale by using RGB to gray function. So this comes under the pre-processing techniques. Noted, it comes under the pre-processing techniques, and therefore that image also will be displayed, and therefore it is named as gray section. Now from this gray image only we are going to select the compression levels. Okay, on the order of second, on the order of discrete wavelet transform for second order, here that particular data will be provided as input. Okay, so how the compression is applied? So from this gray image, whatever we are providing, so this is known as the first level of second order. The first level, it starts for low, 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 high, low, and high, high. So whatever the discrete wavelet transform it is read, it will be stored into the different parts. Okay, so these are the four parts available for the TWT. Now, from this particular variable, this can be taken as a set of variable. So there are different variable. Now here I am declaring a variable, and therefore that particular variable will be splitted into two. In which two parts means LL, low, 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 high, low, high. So into that particular sections, it will be separated. So from that particular separation, therefore we will be displaying what type of level it is, which is for DB1. So the same DB1, the second level decomposition, like LL1, LH1, HL1, HH2. Okay. So here what kind of data here we will be applying means the LL part. They will be applying the 4 decomposition level, and from that we are going to take the input as LL part. So that LL with DB1, then LL2, which is taken from here for DB1. So this is fourth level. Okay, so second level it comes with LL, third level comes with LL1, and fourth level with LL2. Each and every images can be displayed over here, but all everything will be looking in the same format only. There whatever we have taken, it comes under the pattern of there. So for each and every compression, we also have some values. Okay, that is known as compression values. We'll make it as A2 value, AA1. Okay, so now all the particular sections has been displayed over here. Yeah, everything is clear. How this particular decomposition series has been applied means, now take this AA1. So that particular AA1 will be like from the section of this particular data for compression. If you go for AA2, so 2 means from whatever we have stored into the AA1, from that only the second part of compression will be taking, and therefore the rest of the compression will be taken place. And similarly for AA4, and finally all the images will be compressed over there. Okay, so now we can run the code. Now I'm going to take an scan image of the brain for compression purpose. Okay, so now all the compressions has been done. Now let us move to the first. Okay, so this is nothing but the different values of each and every section of image, whatever it has been read for the DWT part. So for each and every purpose like AA1, AA2, whatever we have provided for the display, that values will be displayed over here. Now how the image compression can be varied in the sense, these are the different levels. So this is the original one. So this is gray converted image, and this is the first order of first level of second order compression. Okay, so here you can see how the image has been compressed. Now let us see each and every part. So this is nothing but AA. The first one which you have seen, it is AA. This is AA1, AA2, AA3, AA4, and finally the last decomposition whichever we have seen, that particular AA4 only here it has been applied. So this will be the final compression which we will be training for GLCM purpose, or we will be taking into the neural network, and this is known as the lossy compression. So that particular loss values only here we can see, but anyway we won't be able to see like size functions over here. These are the losses which has been occurred inside the image compression part. So how to use stationary wavelet transform over here. So first CLC clear all close all, taking CD input, and input file will be read, and therefore the plane separations will be done. Okay, in case the plane separation is not applied for the size oriented sections means, we can directly just provide into the color conversion known as RGB to gray, and therefore that image also will be displayed. Okay, so here since I am planning for providing that fusion part like watermark, for that only here 2 sets of images I am providing. Okay, and therefore the same process is done for the another image. First we have to apply the noise removal for that particular image using the median filter of second order. So therefore that is known for median filter over here, that also will be applied over there. And now here we will be applying this stationary wavelet transform. There we have chosen as discrete wavelet transform, which is known as the discrete will be moving from one point to another point. So we cannot be able to predict or that is not a stable one. Stationary, it's nothing but the point will not be moved and it will be in a stable part. Okay. So now here we have declared this variables and we have provided the SWT of second order. So from that, whatever the data we have been previously processed with removal of noise, that image will be taken over here as input. Okay, and from there we will be taking it as SW1. So nothing but the first level. And similarly, all the levels we will be taking it like calling from the previous section, and from that here we will be taking it over to the next section. So this is known as the multiple sections for all the two images whichever we have selected. Okay, so now I will just run this program. So here I am selecting this as image and I am selecting this color image. Okay, so now let us come from the first. Yeah, so here I have taken only the image 1 series. This is the input image, pre-processed image of input, and this is the noise removal of input image 1, and this is the stationary wavelet transform of image 1. Okay, now let us move for the image 2. This particular image 2, it comes under the sections like color image. Okay, because here we cannot differentiate any of the color variations. So the pre-process part, noise removal part, and the compression part. Okay, so here it is completely set as the compression sections. So we can just compare how this particular sections are being applied. Okay, so on this basis only the stationary wavelet transform also will be able to compress an image. And I have forgotten you to show this particular normal colored image in discrete wavelet compression, because we have seen an MRI scan image which is not a color image. Even though it has been converted into grayscale, the features will be varied over there. So once again I will run this and I will provide this as input. Okay, so this is the input image, grayscale, first level of compression. So here you can see how the patterns has been taken over here. Second level, the normal DW, first level, this is second level, sorry for that, third level, fourth level, and the final. So this will be the last level of compression. Here we can see that particular patterns. So that is known as the compressed pattern while compared to the original level. So that makes a difference for the discrete wavelet transform as well as the stationary wavelet transform.
Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.